Hey y'all, I wanted to take you through the bird. So basically I'm starting from the very, very bottom and I'm going to take you to the very, very top. To start, I'm just going to show you sort of the structure of the bird itself. So basically every colored line you see here is a position from one transform to another transform. Those are sort of the basis of the bird's skeleton, and every movement I'm making is based on a controller that you can't see, of course. And I'll start by kind of showing you how that controller sets the poses. So for the skeleton motion, I'm essentially just using a set of blend shapes. So I basically have a pose, and that pose is a list of rotations of each individual bone, quote unquote. And I set those so that when I press the object on the controller, that will affect just that one. For example, this is left wing tuck. And if I tuck just the left wing, that sort of is what the skeleton of the bird will look like. Tuck just the right wing, mirrored version. And you can see if I sort of use all the controls individually, you're seeing those different sliders go all over the place, and it sort of is setting the bird in a bunch of different ways. Obviously, in addition to each position on the skeleton, there's a full basis of the skeleton itself, and that's really useful for determining the directions of where each feather is going to go. So here you can see the full basis of each skeleton and how it moves as you move the bird. The next step is sort of where a lot of the magic comes in, which is to draw the points along where the feather is going to go. So just to show you an example, here's the points along the body where the feathers are gonna go. And all of those points are sort of created in this quite hectic compute shader. So this is where it starts getting really insane and nerdy. So this is for the body. And you can see it's a lot of lines of math to make sure that the body looks good. But essentially what I'm doing to start is I have a compute kernel that sets up the position of these different lines along the body so that it will act in sane ways using the body's transforms. So if we look at just one line here, it's taking all the bases and setting them up along the body so it acts in a sane way. Here we can see it with more lines. What's really nice about this process is it means that we can dynamically change the number of different feathers. So if I want the number of scapular rows to be like 40 instead, I can set that and then I'll get only 40 rows of feathers along. But after I've made these lines, then I essentially need to place a bunch of matrices along those points where the feathers actually are. So these are the different feathers and where they actually go based on information like the scale of the feathers, the different directions. So as you can see, as we move around, it's going to give us new information about where those different feathers go. And then from there, all we need to do is just render the feathers. So here you can see the feathers actually being rendered on top of those matrices. If I remove the matrice debug, we can see the feathers actually along it. So you can see right now that these feathers don't actually fit across the entire body. So I either need to, make it so that there's more columns, like so. Or I can just scale up those feathers. So you can see it's like really nice because it becomes very, very procedural and lets you sort of make some kind of strange birds. So next up is the wings. We don't have to do the full creation of the lines, but you can see here that we've got these debug points on the wings now. And those debug points, as well as just being on the wings, will turn into feathers when we draw the feathers on them. So here we go. This is sort of a version of the full bird. Now I can sort of show you how wild we can get with some of these different things. So there's certain values like the distance from the hip to the tail, the distance from the hip to the spine, the distance from the spine to the shoulder, distance from neck to head. We can get those really funny little like poofs there. Chest to shoulder, make them swole. And of course, as we do this, the whole thing is still simulated in a pretty fun way. Shoulder to elbow, elbow to hand, hand to finger. So we get this sort of like really wide breadth of what the bird can look like. This might crash everything, but I'm gonna give it a go. So now we've got like a very high plumage bird, and you can see the details on the feathers. So what's really cool is it means that I can also just change the model for what the feather is really easily. For example, if I want every feather to be a sphinx instead, I can do that. Let's scale it up to sort of show that now we've got these little sphinxes that every feather is made from. Obviously, pretty hard to tell when you have so many of them. But it is pretty exciting to be able to have that much customizability over what your model is procedurally. It also means we get a lot more customizability of what is actually, how it's actually being rendered. So I can sort of make the feathers point up a bit more or point down a bit more, depending on what direction the bird is facing. I can sort of give some more noise to the bird itself, so we have sort of like a bit more of a organic bird. I can also sort of like make the bird itself flutter. So that sort of is giving us like a bit of movement as the bird flies along. And we can make that flutter move faster. For example, if the bird's moving faster. So again, just to review, we've got the skeleton. The skeleton moves based on blend shapes that I specifically pose. On top of that, there's a basis that gives us more information about the rotation of each transform. On top of that, we draw the points that the feathers will be at. And then after all that, we draw the feathers themselves. So that's the bird. I hope you enjoy, and let me know if there's anything else you want to know about it.